welcome Kaushik. He leads the digital accelerator for Southern California Edison, where his team is responsible for leveraging digital technologies such as cloud computing and AI. They also employ digital methods such as agile development design thinking to deliver business outcomes, to reduce risk and drive customer satisfaction and improve operational efficiency. Southern California Edison is also one of our platinum sponsors. Thank you. And thank you for your support and sponsorship. Mukund will be presenting a talk titled Illuminating Our Path Through Advanced Analytics. Please join me in welcoming Mukund, Jack, and Frank. Thank you.
Thank you, Sudha. Thank you for all the SC audience in the crowd, but also thanks for others for joining us. So we may be overpowering you with the number of greens that we have. So the original talk was electrification of issues through data analytics, and we felt that was a very harsh-sounding word, so we kind of changed it, softened a little bit, had a little bit of play of words on illuminate, so illuminating our path through advanced analytics. I have Jeff and Frank with me, who will also help you share some of the use cases that we have. And towards the end, I'll also talk a little bit about what are some of the problems that we need help with, which is why we are here trying to see if there is talent that we can inspire to come join SC in our noble vision to illuminate our path. So like I said, I'm relatively new to the company. I lead a group called the Digital Accelerator, and our main mission is to employ digital technologies like mobile and advanced analytics to solve really complex business problems. In the note today, what I'll try and illuminate for you is some of the challenges that we are wanting to solve in terms of our priorities and how we think big data and analytics can help us. And rather than just talk about it from a theoretical point of view, we wanted to showcase some very practical use cases that we've actually solved, and then also leave you with a problem that we are still in the process of solving. And if you guys in the room or in the audience are people who have expertise in this space or know of vendors in this space, we'd love to hear from you. So in terms of Southern California Edison, we have a lot of data, and this infographic attempts to prove that. We have about 50,000 miles of territory that we cover. We support about 15 million consumers today. And all of these consumers are generating a lot of inbound calls that are coming in, and it's about 16.6 calls per year. This is not looking at all the chat volumes and all the email volumes that we get. Those are still separate. And we also get a lot of visits to our website, which is also a big source of information in terms of what do our consumers need from us. We support a grid, and the grid is made up of a variety of equipment. The most visible that you all see is the poles that are out in the streets. We have about 1.4 million poles that we currently manage across the 50,000 square miles of our territory. Number of transformers, about 119K miles of line that run through these poles, and a huge number of substations and transformers through which we distribute our electricity. The thing that I did not realize before taking the job is we also manage trees. And you ask why trees are important. We actually track 1 million trees, primarily because some of the trees run in parallel to our grid line. And the branches grow because they have their own pattern to grow, and sometimes they encroach the lines, and that creates things like sparks and may cause a breakage in the line, which may cause fatalities in the region, or more importantly, also cause disruption to the community. So we have to also track the number of trees we have on the line and the vegetation growth along the way, so that we can trim them before you experience a disruption or before we lose a life because of a wire down. So we have a lot of data, and the goal that me and my team at SCE have is to use these data sets that we have to work on our priorities. And I'll quickly touch upon some of the priorities that we feel are important priorities that data and analytics can help solve. We have a goal by 2030 to have 80% clean energy without the carbon footprint without carbon in California. We are using data and analytics to help reduce the risk. We run a fairly distributed infrastructure, so We get a lot of data coming out from the infrastructure in terms of sensors and IoT data. So how do we look at that data set to predict when the equipment is going to fail so that we can replace it before the equipment fails, or where we should be investing our dollars so that we can get the maximum return of investment on the most important things that need to get replaced. We're also using a lot of technology and a lot of data analytics to make sure that we're giving all of our 15 million consumers the best possible service that we can. Today, as consumers, we all have choice. We like the phone, we have chat, we have web, we have different modes of communication. So how do we make sure that all of our services are available through all these modes of choice? And then what is the most important feature or capability that the consumers need through the different channels? So that's, again, and how are we doing in terms of the service that we provide to them on those channels is also a very important data problem that we're trying to solve. We are implementing sensors on the grid, IoT, so that we can start to manage all the data coming from the grid so that we can get better informed of how the grid is performing, what equipment needs improvement, what area of the grid is undergoing some degradation so that we can take rectifiable action. At the end of the day, we want to make sure that we're providing clean, uninterrupted power to our end consumers. Obviously, we want to make sure that our grid is resilient and our grid is operational. So there's a lot of investment in data and advanced analytics around the operational aspect of it. And safety is a huge value system for us, primarily because the work that our linemen and crewmen do is extremely dangerous. And so Jeff will talk about how we are actually leveraging data and analytics to help improve our crew safety, and when they go out of the field and do the work, how are we using data and analytics to bring the safety value to life. So I'll turn it over to Jeff, who will share with you what we are doing in the area of safety and analytics.
Thanks, Mukund. Appreciate that. So I was just taking a look at this incredibly awesome article from the USA Today on the top 25 most dangerous jobs in the U.S. Who can guess number one? Right? Fishing. Because we've all seen those crab guys up there in Alaska. We don't want that job, do we? Number 10 on this list, guys who work the lines. So it's no surprise that Edison has taken a position that safety is our number one priority. That's a really dangerous job. Now, here's the thing. None of us want our power turned off. Right? Because we want to enjoy our air conditioning. We want to look at all that great stuff on Netflix. So we all want our power turned on. The worst scenario is your power's off. Right? That's a really bad scenario for most of us. So imagine the guys who have to do that work with the power on. 400,000 volts running through some of these lines, and you guys are complaining that the power needs to stay on. So let's look at this scenario here. This is an actual picture of what really happens in some of these jobs. What you're seeing in this picture is before the guys go out and do the work, they do this thing called a tailboard. And for any football fans, it's almost like a huddle. We get together, we talk about the work, we get our minds tuned into the work, right? Because we really need to be focused on what we're doing here. Remember all those votes we just talked about? We don't want to die. So these guys, they really focus in, right? It's all about being focused before we do the work. Now, for those of us who do Amazon shopping, we're all quite familiar with recommender systems. We all familiar with those recommender systems? Okay. Imagine if we could use our data to recommend hazards before the job. So what I've been working on really since I joined Edison almost a year ago now is turning that tailboard into a digital recommender of hazard awareness using all the data, our history, etc. Okay. So let's talk about what that looks like. Now I know we only have so much time, and I'm a data scientist. I could go on and on and on about this stuff, okay? I'm going to try, for those who aren't data scientists, not too far into this. But we got lots of data, right? And because we have all that awesome data, what tech can we apply to it that allows us to tackle that problem I just told you about? leaving the power on, we call that working hot, recommending the hazards so that our crew can talk about that work, and potentially offering potential mitigations to that. So what you see on the far left here is all the data that we might want to take a hard look at. I'm going to draw your attention to one or two of these items. At the bottom, we talk about assets. For us, Mukund talked about it. Trees, poles, what's hanging off the pole. Maybe we can talk about complexity of pole. How many services are on the pole? Where's the equipment on the pole? The order of that equipment. So we're able to analyze all of that and effectively come up with some ideas of forced ranking of risk. Now, the risk is interesting from an asset standpoint, but again, that's only one part of this argument. The other part of the argument is the person who's doing the work, the activity that they're doing. So we need to put some kind of risk on the actual asset, but we also need to put some kind of risk on the actual activity itself. So how do we do that? These are the latest technologies from a machine learning standpoint. Computer vision, right? This idea that we can go up to the pole, look at it with a camera, and diagnose if there's something wrong with the pole. That's pretty advanced stuff. So for those of you who are thinking computer vision is only in a Tesla, you're wrong. We use computer vision to analyze our poles. We use computer vision to analyze our lines, which Frank will talk about. We use computer vision to analyze video footage from drones. So computer vision is a big part of what we do. You see, NLP. We talked about all those text messages and all that stuff kind of coming in from our customers. We look at text analytics to try to find interesting activities that are inside our data. And then, of course, we've got traditional machine learning, XGBoost, random forest, deep learning kind of things in an effort to assign probability to risk. So once we've done all that cool tech stuff, the real question becomes, what's the impact on the business? Now, for those of you who are in fact machine learning data scientist people, it's all a lab exercise until it actually goes live, right? And we've all done that lab stuff. I'm sure one of you probably have some kind of lab thing going on this weekend. But it doesn't matter unless it makes it to prod. So for us, what this means is that we want to integrate this algorithm to the work that our crews do in the form of actual activity and systems that they use to drive their thought process. And we've done it in a number of areas. I'll just highlight a couple in the interest of time. One is we want to assign risk to work. I've mentioned that over and over again, but imagine if I could do that in advance, like 21 days in advance. So imagine if I got a lot of smart people in the room who talk about the work before the work happens. You know what happens? They come up with the best solutions. So if I can do that over and over again, that's going to keep our guys safe out in the field. So in closing, I'm always interested in users. Users are a unique collection of people, right? Because you don't really know what people are thinking. So I'm like, okay, are these guys actually going to use this system? So when I get quotes, these are actually real quotes from guys who are out in the field, the guys who climb the poles. You've seen them, right, with the gear on and the hats, with the yellow shirts. So when those guys are telling me, dude or bro, whatever the lingo is, this is going to save some lives. So imagine, as a data scientist, right, you're typically staring at your screen all day, but some guy who's a craftsman, who's a professional, knows how to climb a pole, change the wire, work hot, might not understand all the stats and the math and all the rest, but one thing he does understand, if we can talk about work far in advance, no one's going to get hurt. Everybody's going to go home safe. So when I got that quote, I tell you, the hairs went up on the back of my neck, because that meant he got it. That meant he understood the power of the analytic tool. And there's a couple of other things going on up there, right? It's all about going home safe. And so for us, that's what we're trying to do with our predictive modeling. Thanks a lot for having me. Frank?
Okay, so what he talked about was, when they're out in the field doing tailboards, and in order to prepare for the work. Well, the use case I'm going to talk about is what we have to do in order to prepare for work proactively. In 2011, we had significant windstorms and rain that knocked out significant parts of our service territory. They talked about the trees being next to the lines. We had trees knocked down over 100 poles in some cities like Arcadia. And so at the end of those storms that happened in 2011, Edison said, look, if we have the data, we have to be more proactive in what we do. And so a project was spun up about proactive storm analytics. And what the mission is to look at the historical storms, look at our service territory, look at the historical weather patterns in relation to those storms, and then look at the forecasts. If we know what the forecasted soil moisture will be, if we know what the forecasted winds, rains, if we know all those variables, can we build a predictive model that'll tell us where we'll have significant troubles in our service territory? In particular, what we're looking for is we're looking for areas where we'll have transformers go down, poles go down, overhead lines go down. And with those, we also want to know what's the resources that will be required to replace those, because as you said, if a pole goes down, you got to send a crew out there to replace it, and that takes time, that takes hours. And so because we have a 50,000 square mile service territory, what we do to break down the work is we break it into regions and districts. And so here what you'll see that what we use visualizations to create maps that display the significance of or the impact of weather on our service territory, so that we could predict the resources required to replace them, as well as what assets need to be replaced as well. What we use for the prediction models are probabilistic. We use random forests. So we know that it's not going to be 100% accurate, but we know that, typically a severe storm isn't going to cover our entire service territory, but it'll cover sections of it. And so our predictive models can at least focus on the areas that we do know will need resources, and it could focus on the areas that we know what type of resources we might need because of the prediction models. This is something that runs every day in our production system, and we're using it to essentially be more proactive and respond faster to when we have storms and outages, because of course keeping the lights on is besides safety, is one of our highest priorities. And so the technologies we use R for our models. We use Shiny, and we use databases, Postgres. So it's the things that you guys are learning now that you can apply in the real world, and it matters, because think about it. Like you said, no one likes having the power out, and can you imagine if there's somewhere that we know we have no control of it, the tree's going to knock down the transformer. So, but at least we'd have crews standing, waiting for something to happen, replace it, and you're back up within a couple hours. That's really the ideal situation. We also integrate, we use GIS data as well. We integrate it with our historical outage data, and as well as our outage and resource data. So really it's just a combination of data analytics, and we're even using like the latest cloud technologies, Azure. That's where we're running this, and so it's really great to see that, because I've been here for 17 years and with Edison, and to see how we're continually moving along and using the latest technology, the greatest resources, and hopefully the greatest minds to help us accomplish some of our problems. And with that, I'd like to give it back.
Thanks, Frank. So as you can see from both Jeff's and Frank's work that they have done over the last year or so, I got it. Thanks. We are trying to solve real-world problems, but there's one problem that I think I'd like to speak about and leave that as a problem that we are still in the process of solving. We don't have it solved yet. We are on the path of solving, and I would love to hear people who are doing any research projects in this space, or people who have solutions that they've deployed in this place. We'd love to hear from you on that, and that's to do with field inspection using drones. For those who don't know, the 1.2 million poles that I talked about have to be inspected. When I say inspected, visually, somebody has to go next to the pole, look at the pole, capture some basic statistics about the pole, and make a call whether the pole needs repair or the pole is good. And that information is then used to determine what is the risk that we have within our system. So what we want to do with drone-based inspection, because it takes an army of people to kind of go and inspect these poles, and that takes a long time. And what if a pole is degrading while somebody else is going somewhere else? That creates a risk in the system. So what we want to do here is use drones to kind of go look at our entire transmission lines to see where are we having some issues. And we want the drones to start collecting information which give us information about our assets and how the line's looking, how the conductor's looking, where is there degradation happening on the line. And that's where the problem is. We can know through algorithms and everything else where the line is broken or where there's something that's faulty because you know what that looks like. But what if the thing is degrading over time? Let's say you can take 3 pictures or 4 pictures over a period of 1 year, you'll see degradation happening. So how are you able to predict degradation through images? That's a problem that we still don't know. We still have not solved. We have data that tells us from the grid point of view on how the grid is doing, but we don't have any visual eyes on that. So with the help of drones and the help of other data, we want to be able to predict the degradation that's happening on the line so that we can do better preventive maintenance so that the power really doesn't go down because of an accident, or also replace the equipment or make investment proposals to the commission on where the equipment needs to be changed so we can get more data driven in terms of our maintenance schedule, in terms of the asset replacement strategy, etc. And that's a problem that we are in the process of trying to solve. I would love for some of you or those of you who are interested in the problems that you heard today and want to solve problems like that, we would love to hear from you. We have a talent acquisition team. We have a booth there. We also have a website there. So please do look out for us and check us out, and also come see us sometime. And we'll be more than happy to talk to you interactively, one-on-one, in terms of the problems we're trying to solve. So thank you. We have about 10 minutes or so. We can take some questions.
Yeah, we have 15 minutes.
Question for Jeff. In your scenario, you were talking about very low positives for your predictions. It's a rare event scenario.
Yes, it is.
So how do you compensate for the counterfactuals, things that did not?
Oh, I can? Just too much tech, man. Just way too much tech. You're absolutely right. We've got I call it imbalanced data. I don't know why. This is really corny looking, isn't it? We've got imbalanced data, to your point. So what we want to try to do is, there's a couple of things, and I guess a lot of you are going to experience this for those of you who are considering data science as a career. How do you deal with imbalanced data sets is really the question you're asking. Okay. So there's a couple of things that you can try to do, and that's something that we're battling with. When we set up a lot of our transactional processes, we never really thought that someone was going to actually try to learn from that data. So we've got a data quality issue anyway, right, inside the actual transaction, okay? The second thing that we started doing years ago was that we often have close calls. So the accident didn't happen, but it could have occurred. And luckily we started capturing that because that helps sort of expand our data set a little bit. The other thing that we do is that we also classify our injuries, to your point, actual fatalities, but also other injuries that maybe weren't life-threatening injuries. That too also expands the data set. Now, the last piece that I'll mention is that, as a data scientist, you always kind of hear, you need to know stats, right? Everybody's heard that, right? As a data scientist, right? We've all heard that? Maybe you haven't heard that. Okay. I've heard that. You need to know some stats. Here's a reason why you need to know stats. When you have imbalanced data sets, how do you deal with that? One of the ways that you deal with that is you resample your data to create a bit more of a balanced data set. So that's partially what we do, is we look for ways to resample our data set to create, in other words, whatever that negative event is, you want to sort of emphasize it more so that it stands out in your patterns. The other thing you can do, of course, is use better tech, right? So I might start off with a tool like, say, a random forest, maybe not so good with imbalanced data sets. And then I might use something like an XGBoost, a lot better with imbalanced data sets before moving on to deep analytics or deep learning. So just a couple of answers to your question. Hopefully I gave you a little bit of something there.
Generating, like, for example, outage data, non-outage location, if you're looking at logistic regression, for example, for outage?
Yeah.
You can repeat the question.
So the question was, have we considered, call that bootstrapping, is that okay? Have we considered bootstrapping or auto-generating some data? The answer is absolutely. We don't want to be careful, though, with some of that because, again, what we're really concerned about is putting too much bias inside the model. And so by using our actuals or even our close calls, it's given us enough model performance where we feel reasonably comfortable. Remember earlier when I talked about this is safety, right? So what you want to do is figure out whether or not your model is giving you real results. The way that we know we're getting real results is we've taken it to the field. We've done a little bit of, it's called a hypothesis testing, to see whether or not if that model insight actually makes sense to the guys who actually do the work. But yeah, so we've definitely have done some bootstrapping, but again, we're generally okay now with our model performance given all the data points that we do have.
What about the process that you're using to identify, like through the pictures, the degradation in the assets? Like,
Yep.
have you been successful at, like, let's say you have a picture, and you took a snap, let's say each quarter in a year. How are you identifying, like, what's your success rate in identifying the degradation of the model, or if an asset needs attention now, or it's going to need attention a year from now or 2 years from now?
So right now that's the thing that we're currently working on. So right now, so first of all is images itself. So we were having helicopter data and LiDAR data, and so we have visual data today. And today, every day when we run the drones, we collect all this information and put it in file folders, and humans are actually looking at it to figure out whether a part needs to be replaced or equipment is getting faulty. We are in the process of setting up models to start using computer algorithms to kind of first determine if a part is faulty or not. That's a binary answer, right? A part is faulty, a part is not faulty. I think where the research needs to go, and that's where we are discussing having some experimental projects that we want to start, is once we start collecting this library of information, then how do you find patterns of degradation? And that, to be honest with you, it's a mathematical problem that we don't have the solution yet. And we are hard at work to try and figure out, either through research labs and other kinds of things, on how we have an answer to that problem. But it's something that we are looking into. But we do have real data coming because we're also modernizing the grid. We're getting some real data in terms of how the equipment is performing. So we can also use that to kind of help predict asset failure. But in addition to that, we also want to add visual inspection on top of that, so we can get a better correlationship in terms of this is what the visual is saying and this is what the real data is saying, and how do we then make a prediction that this is actually going to fail in so and so time.
Are you making any of that, like image data or LiDAR data, public for maybe a Kaggle or something that you work on?
Right now, I don't know the answer to the question because there is some of this. So right now, the answer is I don't think we're making it public at this point in time. But if there is interest, that's because this is all infrastructure that is sort of under. It's very sensitive information. And so I think there is a little bit of, I don't think we'll share it publicly, but if the commission requests it through their regular process, if we have to share it, we'll share it. But right now, we're not sharing the data.
Along the lines of like rolling blackout and stuff, I know the next generation of renewables coming online has a bit of influx in its reliability as compared to just power plant generating plants. Have
the susceptibility, like what you're talking about is the susceptibility that the grid experiences due to like things like cloud coverage moving in. So yeah, he's asking how do we accommodate, expanding renewable energy into our service territory when it's susceptible to cloud coverage and things like that. And what we're doing in order to accommodate that is we're just trying to build our models so that they're more accurate, but even like predicting or solar forecast. We need to be able to predict the energy from a load perspective and a renewable perspective. So we're building up our tools and our awareness, what we call DER flexibility to understand that and then accommodate it. It hasn't so far because the penetration is still like within 10%, but when the penetration is a lot higher, it will. So we're moving towards that in our service territory.
Yeah, so I'm 4 months into the company, so I'll give you the answer that I have accumulated through my knowledge. But there are other Edison folks here who can also answer. I think from a commission standpoint, we are obligated to inspect the lines visually. There is an obligation from the commission. What we are trying to do is, in addition to the visual inspection that we have to do, we are trying to establish this method of doing drone-based inspection. The thing is, then if that is successful, I'm assuming that we have to then go make a case to the commission that this is so that is all a big process. So right now we have to do a physical inspection that's absolutely required, but because the territory size being so large, we are augmenting human inspection with some of these camera-based inspection. And I don't know whether the idea of putting a camera on every 1.2 poles has been considered or not. I'll take it back to the team, and it's a good suggestion. Yeah, yeah. I don't know whether Grid Tech, have you guys looked at that? So it's a good suggestion. We'll take it back and we'll see what it comes out of it. Thank you.
Yeah, we have like the high resolution cameras. I know a use case.
On the safety use case, there was an interesting study on construction sites that showed that the technique of presenting the information to the workers had a big effect on the safety.
Mm-hmm.
They're using a VR technique to sort of show them, not this did happen, but this is what could happen.
Right.
Have you guys explored any of those augmented technologies and just your experience with that?
So the short answer to your question is no, we have not explored the virtual reality technology. Our general feeling is that we've got quite a bit of learning and technique that we can do, let's say with our enterprise data and our existing processes. If you talk to the guys who are doing this work, they'll tell you pretty quickly they don't need another app or another thing or more tech or more, no, use other language, of course, when they say that. And so I think what we're trying to do, at least first, to your point, I think what we're trying to do is just take advantage of the low-hanging fruit, let's call it, using our enterprise data, using their existing processes. Let's see if that makes the impact that we're looking for before we go to your point, the next step, which would be more computer vision type stuff to detect mood, right, people's facial expressions before we actually do the work, or simulation of what might happen given all the conditions, those kinds of things.
We are exploring augmented reality for training, though, but not for that type of training.
In fact, HR team has a virtual reality app where they just recently launched at a tech expo that I saw, where they're using virtual reality as a way for new employees who are coming into the company to navigate through the different buildings and also the different forms that they have to fill, etc. So we are doing it in a VR in a very low tech for some very simple use cases. But the direction is to start to see where it makes sense and then start to expand into some of the areas that they've talked about.
Yeah, there probably needs to be some heads-up training as far as getting people adaptive to technology when you're doing on-site inspections. You know, you give them a certain level of advantage with technology. Generally speaking, they'll go to the traditional ways of operating.
True.
True. So when we talk about the field workforce, there's a huge organizational change management component that we have to deal with. So how much of technology you can implement and absorb in a given range of time, especially for the field workforce, is definitely the challenge that we have seen. So you have to slowly grow. Yeah. But what we have seen is the younger workforce that's coming is like, so there are some yeah, absolutely.
As many operatives as you guys have run across within field workers.
Yep.
What's kind of the lead time to get them around their head around something?
You want me to?
Yeah.
Okay. Yeah. Hey, you know what? What I've discovered, when you go out and you tell people you're concerned about them going home at night, that's motivation, right? So we haven't really found anyone who says no, right? Because they all are committed. They all want to go home at night. Because again, everyone recognizes it's a really dangerous job. To Mukund's point, a lot of these workers are younger workers. So they get some of the tech because they all have Facebook, they all have Amazon or whatever. So all we're talking about now is bringing that into their lives, but doing it, as I said earlier, in a way that's integrated, in a way that doesn't overwhelm them with tech. Yeah. Yeah. Yep. Again, absolutely. And remember what I said earlier, let's not distract them, right? So when I'm in that huddle on my tailboard, I really do want to focus in, not be playing around with drones and tools and all the rest. So, but no, I have not found, and I just need to say this, I mean, these guys have been fantastic to work with because, again, they're all incredibly committed to safety and keeping their friends safe. Okay?
Cool.
Yep.
Thank you.
Thank you.
Thank you very much for all your interest, and thank you, the Edison team, for helping me answer some of the questions. Thank you very much.